In this video, I am going to discuss questions on structural isomerism. All questions are subjective questions. In order to write all possible structures for the given formula, I generally follow these 5 steps. This is the pattern I'm going to follow. First, I'll find the degree of unsaturation, double bond equivalence, that is the step 1. After this, I'm going to identify all possible functional groups, like if it is alcohol and ether are functional group isomers. In step 3, I'm going to write all possible positional isomers by taking maximum number of carbon atoms in the principal carbon chain. For example, if you have compound with 6 carbons, first I'll take a 6 carbon chain and I'll change the position of the substituent or position of the functional group. That is in step 3. In fourth step, after completion of this, I will decrease the length of a principal carbon chain. For example, earlier I took 6 carbon chain. Now I am going to take a 5 carbon chain. In that 5 carbon chain, I will write a positional isomers by changing the position of the functional group or substituent. After completion of this pattern, so 6 carbon chain, 5 carbon chain, 4 carbon chain, 3 carbon chain. After that, I will write a functional group isomer. Even for functional group isomer, I will follow the same pattern. Like for example, if it is initially aldehyde, I'll repeat the same pattern even for ketones. Let us apply the above discussed pattern. Here the instruction is given clearly, write all possible structures for the formula C4H10. So C4H10 is the given molecular formula. In the first step, I am going to find degree of unsaturation. Degree of unsaturation, number of carbon atoms plus 1 minus number of hydrogen atoms by 2. So degree of unsaturation is 0. Therefore, this is the compound going to have alkane structures. C4H10, this formula indicates a alkane. So in that situation, according to the given pattern, first I'll be writing chain with maximum number of carbon atoms, principal carbon chain with the 4 carbons. So this is 1, 2, 3, 4. There is no functional group, there is no substituent, so there is no chance of writing any positional isomer. So 4 carbon chain is only 1. Then I will write 3 carbon chain. 3 carbon chain I'll be writing like this. So these are the two possible isomers, two possible structures of C4H10. One is N-butane and another one is isobutane. So one is butane, another one is 2-methyl propane. So these are the structures for the formula C4H10. Now let us solve another question. The given formula is C5H12. Same pattern I'm going to follow. The first step, degree of unsaturation, I'm going to find. Number of carbon atoms 5 plus 1 minus hydrogen atoms by 2. Again degree of unsaturation is 0. Hydrocarbon with a 0 degree of unsaturation, the possible structures are alkanes. After completion of this, first I will write only 5 carbon chain. So this is 1, 2, 3, 4, 5. Then I will decrease the number of carbon atoms in the principal carbon chain like this, 4 carbons. Now I have to keep one methyl group as substituent. You keep either here or here, the result is same. Don't write the substituent at a terminal place. Don't write any alkyl group or methyl group at a terminal place. That will obviously coming into the longest chain. You cannot write a methyl group here, you cannot write a methyl group here, but you can write here or here, the result is the same. So this will be another possibility. So we cannot, first I wrote 5 carbon chain. Positional isomers are not possible for 5 carbon chain. 4 carbon chain I wrote, but here I cannot write any positional isomer, because even if you write a methyl group here, the result is same. Now obviously I have to go for 3 carbon chain. As I discussed earlier, you cannot write alkyl groups here, they will be coming into the longest chain. You have only one option. So totally 5 carbon atoms are present. Already 3 carbons are written, 2 more carbons. Therefore this one, this is actually 3 carbon chain. Maybe you are thinking about something like this, like why should I take only 2 methyl groups, why can't I take ethyl group? If you write like this will become the longest chain and these two are identical. these two are identical. Whenever you get a doubt, give the IUPAC name. If you are getting the same IUPAC name for the two structures you have drawn, obviously they are said to be identical. So 3 carbon chain, don't write ethyl group. If you write ethyl group, this will become the longest chain. 4 carbon chain already I wrote. Therefore, these are the all possibilities. There are no other possibilities. This is pentane. This is 2 methyl butane, and it is 2 comma 2 dimethyl propane. N-pentane, isopentane, neopentane, common names. And this one chain isomers, this one and this one also chain isomers, this one and this one also chain isomers. So ultimately the answer to this question will be 3. And here is another question: write all possible structures for the formula C6H14. Same pattern I'm going to follow. So degree of unsaturation, so number of carbon atoms plus 1 minus 14 by 2. So degree of unsaturation is 0. Hydrocarbon with 0 degree of unsaturation, the possible structures are alkanes. So the pattern you understand properly. First I am writing 6 carbon chain, 3 4 5 6. There is no branch, therefore no positional isomers for this. Now let me take 5 carbon chain, like this, 5 carbons. Already told you, see here 5 carbons already have written. Totally there must be 6 carbon atoms. That means another carbon will be present as methyl group. You can't write methyl group at a terminal place because that is obviously coming under 6 carbon chain. You write here or here, the result is same, because if you write methyl group here, numbering will be started from this side. If you write methyl group here, numbering will be started from this side. So this one are identical. So here one methyl group. And if you can recollect the pattern, I'm going to write positional isomer for this. So here you can write methyl group here. So there are no other possibilities. Now I'm going to 4 carbon chain, like this. So totally there are 6 carbon atoms. Already 4 I have written. You need to write 2 more carbon atoms. You can write 2 methyl groups at the same carbon, like this. 2 methyl groups I'm going to write branches, like this. Again I'm writing 4 carbon chain, methyl groups on adjacent carbons. Even if you are thinking about why can't I write like this, so here this one and this one are identical. So these two are the 4 carbon chain. So this is definitely not possible. Maybe if you are thinking about a ethyl group again, for example, if you write ethyl group, so what happened, this will be the longest chain, 1 2 3 4 5. So 5 carbon chain already we have written. In fact these two are identical. So this is about 4 carbon chain. Let us try for 3 carbon chain whether it is possible or not. So totally 6 carbon atoms. Here already 3 carbon atoms are completed. If you want to write any alkyl substituent, that should be only at a middle carbon. So here like this, and like this you have to take, there is no option. And this is again 4 carbon chain. 4 carbon chain at a second place, 2 methyl groups. In fact these two are identical. So these are the possibilities. You just think about other possibilities, but definitely there are no other possibilities. This is the first one, second one, third one, fourth one, and fifth one. Quickly, n-hexane, this is 2 methyl pentane, 3 methyl pentane, 2 comma 2 dimethyl butane, 2 comma 3 dimethyl butane. These two are definitely chain isomers. These two are positional isomers. These two are positional isomers. 2 and 4 are chain isomers. 3 and 5 are also chain isomers. So this is about C6H14. Ultimately your answer is 5. Let us move on to the next question. Here the molecular formula given is C4H8. Same pattern I am following. First I am going to find the degree of unsaturation, number of carbon atoms plus 1 minus number of hydrogen atoms by 2. Degree of unsaturation is 1. The possible structure for C4H8 with the degree of unsaturation 1. So the possibility, the first possibility, alkene structures are possible. Cycloalkanes are also possible. First, let us write alkene structures. As I told you before, first I will take all 4 carbon atoms in the principal carbon chain. I'll keep double bond at first place. Again I'll take 4 carbon chain, but I'll shift the position of double bond. If you are thinking about writing this particular thing, you can write, but these two are identical. But-1-ene, this is also but-1-ene, therefore this is not the isomer, hence this should be discarded. Only 1 butene and 2 butene. Next, 3 carbon chain, 1 carbon is present as a branch. You can put double bond here or here or here, the result will be same. So what does it mean? If you put double bond here, this is the longest chain and the compound is 2-methyl propene. If you keep double bond here, this is longest chain. Again the same IUPAC name, you can see 2-methyl prop-1-ene. Even if you write double bond at this position, this will be the longest chain, and here this is 2-methyl prop-1-ene. So most importantly, these 3 positions are identical. Anywhere you can write double bond, the result is the same. So there is no other possibility. So this is but-1-ene, but-2-ene, 2-methyl propene. These are the alkene structures. Next possibility, cycloalkane is also possible. Since there are 4 carbon atoms, I am taking cyclobutane. Cyclobutane. Next, cyclopropane derivative I am going to write. These 3 carbons are identical. You can write a methyl substituent either here or even here. The result will be same. That's it. So this is the 4th isomer and this is the 5th isomer. So these are the 5 structures possible for C4H8. 3 are alkenes structures and 2 are cycloalkanes structures. These 2 are chain isomers. These 2 are positional isomers. These 2 are chain isomers. These 2 are ring chain isomers. You take all possible combinations and think about what is the relation between that particular pair. So that will give you more clarity on the definition of a structural isomer. The next question, here the formula given is C5H10. Same pattern I am following. Degree of unsaturation, number of carbon atoms plus 1 minus number of hydrogen atoms by 2. Degree of unsaturation is 1. Hydrocarbon with 1 degree of unsaturation, the possible structures are alkenes and cycloalkanes. Same pattern. First I will take 5 carbon chains, 1, 2, 3, 4, 5. Position of double bond here. 1, 2, 3, 4, 5. Position of double bond here. 1, 2, 3, 4, 5. If you write double bond here, the result will be same. So what does it mean? In this case, numbering is started from right side, double bond is at second place. Numbering will be started from left side, double bond will be at a second place. So these two are identical. Now let us move on to 4 carbon chain. 4 carbon chain. Substituent should be kept either here or here, the result is the same. So here I am keeping substituent methyl group. Now you write double bond at this place or at this place, the result is same because these 2 carbons are similar. If you write a double bond here, this will be the longest chain. If you write a double bond here, this will be the longest chain. So one possibility like this. Again I am taking 4 carbon chain. Again I am taking 4 carbon chain. I am shifting the position of double bond. And here the substituent is like this. Again I am taking 4 carbon chain. And here substituent at this place, double bond at this place. So you can see numbering is from left side. Methyl is at the second place. So position of double bond is different. And here this is 1, 2, 3. So here methyl group position we changed. So these two are not identical. That's what I am trying to convey. Even if you shift this methyl group here, this and that will be same. So there are no other possibilities in 4 carbon chain structures. Now let us try for 3 carbon chain, whether it is possible or not we have to decide. So here totally this is 3 carbon chain, but you cannot write a double bond at this place because carbon is already having 4 bonds. Therefore, you cannot write a double bond. So 3 carbon chain is not possible. So these are alkenes structures. We can also write a cycloalkanes. So that is a 5 carbon chain, that is a cyclopentane. 4 carbon chain methyl substituent, 3 carbon chain 2 methyl groups on same carbon, 2 methyl groups on adjacent carbon, ethyl group. So these are the possibilities. So here this is the first one, second one, third one, fourth, fifth, 5 are alkenes, 6, 7, 8, 9 and 10. So 5 are ring chain structures. So these are the total isomers of a C5H10. Here the formula given is C6H12. Pattern is the same. Finding degree of unsaturation, number of carbon atoms plus 1 minus hydrogen atoms by 2, degree of unsaturation is 1. Hydrocarbon with the 1 degree of unsaturation, the possible structures are alkenes and cycloalkanes. First, let us write all alkene structures. Pattern is the same. I will take 6 carbon chain first, like this. You can write the double bond at this place between first and second. Again 6 carbon chain we are taking. I am changing the position of double bond. One more 6 carbon chain, I am changing the position of double bond again. Double bond at first place, double bond at second place, double bond at third place. Even if you write another structure by keeping double bond at this place, that one and this one will be same because position of double bond. If you write a double bond here by removing this, numbering will be started from right side, then the double bond at second place. This one is also having the same thing. So 6 carbon chains are not possible. No other possibilities. Now let us move on to 5 carbon chain. 1, 2, 3, 4, 5. You can write methyl group here or here, the result is the same. First I am writing methyl group here. Now you can write a double bond at this place or at this place, the result will be same. I am putting double bond here. Again I am writing 5 carbon chain, methyl group. I am changing the position of double bond. Again I am writing 5 carbon chain, methyl group. I am changing the position of double bond. Again I am writing 5 carbon chain, methyl substituent. I am changing the position of double bond. 100% there are no repetitions. You can see position of double bond. You can see position of double bond 1, methyl is at 2. Double bond at 2, methyl is also at 2. Double bond at 2, methyl is at third position. Double bond is at first position, methyl is at fourth position. Now again I am writing 5 carbon chain only, but methyl group is here now. So what I am trying to convey, you put a double bond here or here, the result is same. You put a double bond here or here, the result is same. But if you put a double bond here, the result will be different because that becomes a 4 carbon chain. So first I am keeping double bond at this place. 1, 2, 3, 4, 5. Double bond at this place. Even if you want, you can write a double bond here, that and this will be same. If you write a double bond here, so obviously this one, and when you write a double bond here, the result is the same. Now let us move on to 4 carbon chain. 1, 2, 3, 4 carbon chain. So double bond at this place I am writing. In fact, totally there are 6 carbon atoms. So you have to write a methyl groups. For example, if you are writing methyl groups, Here only for chance of writing one methyl group, here one methyl group, 1, 2, 3, 4, two methyl groups on same carbon like this. Again 4 carbon chain we are taking. Instead of methyl group, I am taking ethyl group like this. Now let us change the position of double bond. Double bond is here. Now you have a chance of writing two methyl groups. Here one methyl group, here one methyl group. If you are trying for ethyl group, that is not possible because this will be the longest chain and that is becoming a 5 carbon chain. So that is not possible, and these are the possibilities. 3 carbon chain, however, it is not possible. It was not possible in previous example, so obviously it is also not possible now, but still if you want, I'll try like this. And if you write a double bond here, this will be the longest chain. So 3 carbon chain is not possible. If you want, you can try and you will get the same conclusion. So fastly, so this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 alkene structures. We can also write cycloalkanes. In case of a cycloalkanes, first cyclohexane, cyclopentane with one methyl group, cyclobutane with two methyl groups on same carbon, two methyl groups on adjacent carbon, two methyl groups on opposite carbons. We can also write a ethyl group like this. No other structures of a four membered ring. Three membered ring, we can write a three methyl groups like this. Three methyl groups on different carbons we can write. We can write a ethyl group and methyl group. We can write ethyl group and methyl group on adjacent carbons. We can also write a N-propyl group. Even we can write a isopropyl group. So there should be no confusion. Three carbons you are covering, remaining three carbons, so three methyl groups. Two are on same carbon, one on adjacent carbon. Three methyl groups like this. No other possibility with three methyl groups. Ethyl and methyl on same carbon, ethyl and methyl. Once N-propyl is possible, then isopropyl is also possible, and these are the ring structures 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So totally 12 plus 13, so 25 structures are possible. 25 structures are possible, but in competitive exam they will impose some condition how many alkenes are possible with the 5 carbon chain, how many alkenes are possible with the 4 carbon chain, how many 4 membered rings are possible, like that they'll impose a condition so that we can do it fastly. Next one, molecular formula given is C5H8, but he is asking only alkyne structures. Alkyne structure, already he is saying alkyne, so need not to calculate a degree of unsaturation. Even if you calculate, you will get a 2 only. So straight away I am writing same pattern I am following. 5 carbon chain, triple bond, 5 carbon chain, triple bond. Even if you write a triple bond here, that is at a second place, there is no other 5 carbon chain. Let us try for 4 carbon chain. One substituent should be here only. You cannot write a triple bond here because already this carbon is having 3 bonds. So we cannot write a triple bond here. We cannot write a triple bond here. The only option, you can write a triple bond here like this, and there is no other 4 carbon chain. Next 3 carbon chain, let us try 3 carbon chain. It should be like this, and we cannot accommodate a triple bond, so 3 carbon chain is not possible. So in case of alkyne isomers, pent 1 ine, pent 2 ine, 3 methyl, butanine, and these are the three isomers of a C5H8. The next molecular formula given is a C4H10O. Pattern is the same. First, let us find degree of unsaturation. Number of carbon atoms 4 plus 1 minus number of hydrogen atoms by 2. Oxygen will not affect the degree of unsaturation. When you are finding degree of unsaturation, oxygen atoms number does not disturb in the formula. Therefore, here the degree of unsaturation is coming to be 0. Degree of unsaturation is 0 and there is one oxygen. The possible functional groups are alcohols and ethers. Cn H2n plus 2O. With this formula, two different functional groups are possible. One is alcohol, another one is ether. First, let us write alcohol isomers. 4 carbon chain, OH at first place. 4 carbon chain, OH at second place. 4 carbon chain, OH here. These two are same. Therefore, this is not an isomer, that is identical. There are no other 4 carbon chains. Now, let us take a 3 carbon chain. You write OH here or here or here, the result is same. If you write OH here, this is the longest chain. Methyl is at second place. If you write OH here, this is the longest chain. Methyl is at second place. If you write OH here, this is the longest chain. So, you just see this one and this one are similar. You can write anywhere, the result is the same. But this will give you a different alcohol. Therefore, this will be a different alcohol. So, these are the possibilities. 4 carbon chain, positional isomer, 3 carbon chain and positional isomer. So, these two are positional isomers, these two are chain isomers, these two are chain isomers, these two are positional isomers, and these are the 4 alcohols possible. Now, let us write ethers structures. Oxygen. Totally, there are 4 carbons. Let me take 2 ethyl groups like this. Instead of taking 2 ethyl groups, one is methyl, another one is propyl. Propyl groups are 2. Clearly, in one of the videos, I explained how to identify alkyl groups. That will be very much useful. Propyl groups are 2. One is N-propyl, another one is isopropyl. Like this, 1, 2, 3, 4 alcohols, 1, 2, 3 ethers. So, these two are metamers, these two are positional isomers because this is 1-methoxypropane and this is 2-methoxypropane. Position of methoxy group is different. So, any one from these 4, any one from these 3, they are functional isomers. Here we have 4 isomers, you take any one. Here we have 3 isomers, you take any one. The relation will be, they will be functional isomers because one is alcohol functional group, another one is ether. Totally 7 isomers are possible. The next molecular formula given is C5H12O. Same pattern I am going to follow. So, degree of unsaturation, number of carbon atoms plus 1 minus 12 by 2. So, that is 0. Degree of unsaturation is 0 and there is one oxygen. The possible structures are alcohols and ethers. First, let us write alcohols. Pattern is the same, 1, 2, 3, 4, 5 OH, 1, 2, 3, 4, 5 OH, 1, 2, 3, 4, 5 OH. You see, if you follow this pattern, it will be very much useful. Pentane 1 ol, pentane 2 ol, pentane 3 ol. Now 4 carbon chain. fix methyl group here. Now this one and this one will be same. You write OH here or here, the result will be same. Therefore first I am writing OH here, next I am writing OH here. Now OH is here, again 4 carbon chain only. Now OH here. If you have any doubt, you can start giving IUPAC name. So 2 methyl butane 1-ol, 2 methyl butane 2-ol, 3 methyl butane, numbering will be from right side. So here this is 3 methyl butane 1-ol. So here methyl group and OH, first you fix a carbon methyl group position same and change OH group. So this methyl group you write here or here, the result will be same. So this is about a 4 carbon chain. Let us take the possibility of a 3 carbon chain. 3 carbon chain like this. Now you write OH here or here or here or here, the result will be same. Like this, neopentyl alcohol. So this is 1, 2, 3, 4, 5, 6, 7, 8. 8 alcohols are possible. Next, ethers are also possible. When you are writing ethers, first you take oxygen. Totally we have 5 carbons, 2 carbon chain, 3 carbon chain. Once our propyl group is possible, immediately you go for isopropyl also, like this. So 2 plus 3 combination. Now you go for 1 plus 4 combination, methyl group and butyl. Again, butyl groups are 4. Butyl groups are 4. So this is N-butyl, isobutyl, secondary butyl, tertiary butyl. Butyl groups, one time investment. If you know how to write the butyl groups, it will be easy for you. If you want, you just go and watch that video. There I explained all alkyl groups. So C5H12O, 8 are alcohol isomers, 1, 2, 3, 4, 5, 6. So totally 6 are ether isomers. In the next example, the given molecular formula is C3H9N. First, let us find degree of unsaturation. Number of carbon atoms plus 1 minus number of hydrogen atoms minus number of nitrogen atoms by 2. So degree of unsaturation, so this is 3 plus 1 4, 9 minus 1, so that is 8 by 2, 4 minus 4, that is 0. Degree of unsaturation is 0 and there is 1 nitrogen, so the possible functional group is amine. It can't be cyanide because in case of cyanide degree of unsaturation is 2. Even it cannot be isocyanide because even in case of isocyanide degree of unsaturation is 2. So degree of unsaturation is 0 and 1 nitrogen, no oxygen. The functional group, possible functional group will be amine. So first let us write all possible primary amines, secondary amines, tertiary amines. I will follow that pattern. First I am taking 3 carbon chain, NH2 group here, 3 carbon chain, NH2 group here. Both are primary amines and they are positional isomers, propane 1 amine, propane 2 amine. Next let us move on to secondary amines. When you are writing secondary amines, so here totally there are 3 carbons. One is methyl group, another one is ethyl group. There is no other possibility, only one secondary amine. Next we have to go for tertiary amine. In case of tertiary amine, nitrogen is attached to 3 alkyl groups and there are only 3 carbon atoms. So this is the procedure. So already I told you in the previous video also, need not to find the number of hydrogen atoms. You check number of carbon atoms, number of heteroatoms and degree of unsaturation. Once a degree of unsaturation is maintained, need not to waste the time by counting number of hydrogens. So totally 4 isomers are possible. So in this, these two are positional isomers, these two are functional isomers, this one and this one are functional isomers. Primary amine, secondary amine, tertiary amine, totally 4 isomers are possible. The molecular formula of the next compound is C4H11N. Let us do it fast. The same procedure. Degree of unsaturation. Number of carbon atoms plus 1 minus number of hydrogen atoms minus number of nitrogen atoms by 2. So 4 plus 1 5, 11 minus 1 10 by 2 5, 5 minus 5 that is 0. Degree of unsaturation is 0 and there is 1 nitrogen. The possible structures are amines. So first let us take a primary amines. 1 2 3 4, 4 carbon chain. 1 2 3 4, 4 carbon chain. 1 2 3, 3 carbon chain. Same procedure. You can write NH2 here, here, the result is same. I am writing here NH2. Similar model we did in case of alcohols. You can write NH2 here also. N-butyl group, secondary butyl group, isobutyl group, tertiary butyl group. So here 4 carbon chain, 3 carbon chain. Now let us move on to the functional isomer secondary amine. So this is totally 4 carbons are present in the compound. One is methyl, another one is N-propyl. Once N-propyl is possible, isopropyl is also possible. Like this 1 plus 3 combination. Next one is 2 plus 2 combination. Ethyl group, ethyl group. These are the secondary amines. Now tertiary amine. In case of tertiary amine, so this is the only possibility. So if they ask number of primary amines, 4. Number of secondary amines, 3. Number of tertiary amines, 1. In the next example, the molecular formula given is C3H6O. But here they are asking to write only aldehydes and ketones structures. Aldehydes and ketones. Already they are saying aldehydes and ketones and need not to calculate a degree of unsaturation. Even if you calculate, you will get a degree of unsaturation 1. So first let us write aldehyde. This is propanol. Aldehyde is a chain terminating functional group. You cannot change the position of aldehyde group. 3 carbons. Length of carbon chain also we cannot change. So there is no other aldehyde. Next possibility ketone. This is the only place you have chance. There is no other possibility. So only 2 isomers are possible. One is aldehyde, another one is ketone, and these two are functional group isomers. Here they gave the same molecular formula C3H6O, but they are asking you to write cyclic structures. Cyclic structure. And if you calculate, you will get a degree of unsaturation 1, but you have to write a degree of unsaturation not in the form of pi bond. You have to write a degree of unsaturation in the form of ring. Therefore, the possibilities, one is cyclic alcohol, another one is a cyclic ether. Alcohol functional group I am writing. You write OH here, here or here, the result is the same. I am writing OH here. There is no other alcohol isomers with this. We can write cyclic ethers also, but in that cyclic ether, instead of 3 carbons, I am taking 1 oxygen. Another carbon should be methyl group. This position and this position both are same, and this will be one possibility. So here this is alcohol isomer, this is ether isomer. The relation between these two, they are functional group isomers. In the next example, the given molecular formula is a C4H8O and the condition they imposed aldehydes and ketones. So first let us write aldehydes. Aldehyde is a chain terminating functional group. So only one possibility in 4 carbon chain. Now I am moving to 3 carbon chain like this. Now you can write aldehyde here or here or here, the result is the same. So aldehyde isomers are only 2. Now ketones 1, 2, 3, 4. Ketone functional group you write here or here, the result is the same. And 3 carbon chain, if you try to give ketone we cannot write. So here ketone means here already 3 bonds are present. So ketone with 3 carbon chain here is not possible. So totally 1, 2, 3 isomers are possible. These two are chain isomers. This one functional isomer. This one and this one also functional group isomer. In the next example, the given molecular formula is C5H10O, and again they are asking aldehydes and ketones. I am going to follow the same pattern. Aldehydes I am writing first. 5 carbon chain I am taking. Aldehyde at a terminal place always. Now 4 carbon chain I am taking. Aldehyde is always at a terminal place. Here methyl substituent. Again 4 carbon chain. Here methyl substituent. You should not write here, because if you write here that will be coming into the longest chain. Now let us write a 3 carbon chain like this. Totally 5 carbon atoms are present. All these carbon atoms are identical. Anywhere you can write aldehyde functional group, that will be same. So you can see here carefully, aldehyde with the 5 carbon chain, aldehyde with the 4 carbon chain, methyl at second place, aldehyde with the 4 carbon chain, methyl at third place, and this is 3 carbon chain and there are 2 methyl substituents. So here these are the aldehydes. Now let us go for ketones. When you are writing ketones, this is a C double bond O. Totally we have 5 carbon atoms. 1 carbon already I have written. Remaining 4 carbon atoms. Remaining 4 carbon atoms you can distribute equally like this. You can distribute like this ketone. When you are writing ethers and ketones, better you follow this, it will be easy. 2 plus 2 combination. Now 1 plus 3 combination. Methyl and N-propyl. When methyl and N-propyl are possible, methyl and isopropyl is also possible. 100% these are the 3 isomers you are going to get. So aldehydes 1, 2, 3, 4, ketones 1, 2, 3. So total 7 isomers are possible for this structure, 4 aldehydes and 3 ketones. In the next example, molecular formula given is C5H10O. The condition imposed, he is asking us to write only cyclic alcohols. The condition is clear, cyclic alcohols you are writing. So first 5 carbon chain, all 5 carbons are identical. Anywhere you can write a OH group. Cyclopentanol. 4 carbon chain, methyl substituent, OH group. You can write here OH group. You can write here OH group. You write here or here, the result is the same. OH group, here the result is different. So these are 4 carbon chains. Now let us move on to 3 carbon chains. You can write ethyl group like this. Now OH group here, you just observe how I am writing. This is the easiest procedure. OH here, you write the carbon skeleton, then possibility OH here. After that, you write OH here or here, the result is same, like this. In 3 carbon chain, let me take methyl groups like this. You write OH here or here, the result is same. You can't write OH here, but you write OH here or here, the result is same. Why it is same, you think? So why should I take 2 methyl groups on same carbon? You can take like this also. But fortunately what happened, this position and this position is identical. This position and this position is also identical. Therefore here one possibility, carbon skeleton You just observe how I am writing OH like this. You write here, this will be the first one will be repeated, right? And the next one, methyl group, OH here. So these are the possibilities, cyclic alcohols. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So if you can write the carbon skeleton and change OH group position, it will be easy. You will not miss any structure. So this is about cyclic alcohols. Next example, the given formula C6H12O, imposed condition aldehydes and ketones, 6 carbons. First let us write all aldehydes, 3, 4, 5, 6. Aldehyde is a chain terminating functional group. 6 carbon chain, 5 carbon chain, aldehyde, methyl at this place, 5 carbon chain, methyl at this place, 5 carbon chain again, methyl at this place. There is no other 5 carbon chain for sure. Now 4 carbon chain, you just observe how I am writing, methyl on same carbon, 4 carbon chain, methyl on adjacent carbons, 4 carbon chain. If you write ethyl group, it will become 1, 2, 3, 4, 1, 2, 3, 4. Yes, this is also 4 carbon chain. So 4 carbon chain with the 2 methyl groups immediately, 4 carbon chain, 2 methyl groups. I missed 1 4 carbon chain like this, 2 methyl groups here. So this is a 4 carbon chain aldehydes. These are the aldehydes. And in case of ketones, when you are writing ketones, already I told you, this is C double bond O, 6 carbon atoms, already one oxygen is written, 6 minus 1, that is 5. So 5, let us take a 2 plus 3 combination first. Once N-propyl is possible, immediately you write isopropyl. So 2 plus 3 combination is over. Next to 1 plus 4 combination. In case of 1 plus 4 combination, N-butyl, secondary butyl, isobutyl, tertiary butyl. If you learn butyl group, it will be very easy to identify. So these are the possible isomers of C6H12O, 1, 2, 3, 4, 5, 6, 7, 8 aldehydes, 1, 2, 3, 4, 5, 6 ketones. So these are the possible isomers of the given molecular formula.